When talking about scaling an application, the first fundamental principle is to understand load distribution, which is the science of splitting the load of an application across several processes and machines. Scalability can be achieved in following three dimensions: x-axis, y-axis, and z-axis. In x-axis scalability, we clone the same application n times and let each instance handle one of the nth workload. In y-axis scalability, we decompose by services or functionality, like in an application separating the administrative part and separating the services responsible for user authentication, thereby creating a dedicated administrative and authentication server. In z-axis scalability, we split by data partition. This technique is often used in database, also known as horizontal or vertical partitioning. In this setup, there are multiple instances of the same application, each of them operating on a partition of data. For example, we could partition the users of an application based on their location and surnames. In traditional web servers being multi-threaded, they could take advantage of all the processing power of the server. But Node.js servers being single-threaded are scaled much sooner than the traditional servers. Now coming to our previous term, load balancing. We have a cluster module in Node.js which is built in the core of Node.js libraries. Cluster module can distribute the load of an application across different instances running on a single machine. As you can see on the screen, there is a primary process and there are 4 worker processes running side by side on a single port 8000. The incoming request, which comes to the main process, also called the master process, can spawn as many workers or processes as number of CPUs available in the system, which allows Node.js application to take advantage of all the computing power available in the system. The cluster module uses a round-robin load balancing algorithm. Now you can question, what is round-robin load balancing algorithm? The round-robin load balancing algorithm distributes the workload evenly across all the workers on a rotational basis. The first request is forwarded to the first process, the second request is forwarded to the second process, and the third request is forwarded to the third process. And the list goes on. When reached the end of list, the iteration starts over again. Now we will see it in action, and we will build a small Express server, and we will check the load that server can handle without the use of cluster module using autocannon npm package. Then we will test our application load using the cluster module. First of all, we will go to package.json file and see I have autocannon version 7.10.0 and Express 4.18.2 installed locally already. So if you want to install these packages, you can use npm install autocannon and npm install express. Now we will create index.js file and we will write our code in it. As we have express installed already, we will import express and we will also import PID from process package. Express function is a top level function exported by express module which creates an express application, and we will store it in a constant variable called app. Now we will make app listen to port 3000 and we will also log the port with process ID. Now we will register a get route with a handler function. In that handler, we will take a value variable with a value of 1,000,000, and in a while loop, we will decrement it until it gets 0. We do it for the sake of some processing by the handler. We will also log the process ID and we will return an OK response from the handler. Now since we have autocannon installed locally, if we check the node modules directory and we go to the .bin directory, we see the autocannon command. So we will use the same command with this path. But before we do so, we will run our server. As you can see in the terminal, our server is running on port 3000 with the process ID 5136. Now we will use the autocannon command that we talked about with two options, -c, which stands for concurrent connections, and -d for duration in seconds. So we will load our server with 200 concurrent requests for 10 seconds and we will see the result. As you can see, our handler is handling the process with process ID 5136. Now you can see our server can serve 2276 requests per second without using cluster module. Now we will load our server again with the same number of concurrent requests for 10 seconds. And we will compare the results with the previous one. As you can see, this time we got 2410 requests per second, so the average value will be around 2300 requests per second. In this tutorial, we will start from where we left off in the last video. If you haven't watched it, click on the I button and go and watch it. First of all, we will import cluster module. Thereafter, we will import operating system module. We are importing operating system module for getting number of CPUs available in the system. So we will start as many processes as number of CPU cores in the system to take advantage of all the available processing power. Now there are two things we can check in the cluster module. If you're using node version 16 or later, we have to check cluster.isPrimary. Otherwise, you have to check cluster.isMaster. Since cluster.isMaster is deprecated after version 16, I am using node version 18.12.1, so I am gonna use cluster.isPrimary, which returns true if the process is primary, and we will use cluster.isWorker, which returns true if the process is not primary. Then we will get available CPUs in the system. To get that, we will use operating system.cpus method, which returns an array, and we will use cluster.fork method for each CPU core available in the system, which can be called from primary process and spawns a new worker process for each CPU. When cluster.fork is executed from the primary process, the current module index.js is run again, but this time in the worker mode. Since cluster.isWorker is set to true and is primary to false, when the application runs as a worker, it starts a new HTTP server. Now we will move all our code we did in the last chapter, including importing process ID and calling express function, so that each time when cluster is forked and runs our index.js module, it will start a new HTTP server. Now we will run our code and inspect it in the terminal. As you can see in the terminal, there are 8 processes with the given process ID are running, controlled by the primary process. As I am using Mac M1, I have got 4 performance and 4 efficiency core. Total 8 cores, therefore 8 processes are running. Now we will load our server with autocannon with 200 concurrent requests for 10 seconds. And we will check how many requests can now it serve using cluster module. As you can see, requests are being served using different process IDs. Now you can see it on the terminal that it can serve 5256 requests per second. If we run the test again, it can now serve 6118, so the average value will be around 6000. In previous video, when we checked it without using cluster module, it could serve 2300 requests per second, and now it can serve 6000 requests per second using cluster module, which is nearly 3 times faster. And that's how we can scale our server using cluster module in NodeJs. So this is the 5th part of our scaling of the applications in NodeJs. In this video, we will start where we left off in the last video, where we discovered the performance increase obtained by scaling our application across multiple processes. But we have a problem with this approach. Let's see what the problem is. The problem is when processes are serving requests, what if some error comes into picture? Then our server will shut down. But now that we have scaled our application across multiple processes, when one process goes down, rest available processes can still serve the incoming requests. But what if all our processes go down? Then the server will stop serving requests, as no process can serve the request because they all are down. This pattern is pretty easy to implement using cluster module. Let's see this in action. Now we will use index.js from previous section and modify it in such a way that it goes down after a random interval of time. We will use setTimeout method to simulate this action. Now inside of our setTimeout method, we will use math.ceil and math.random function to generate random number of seconds between 1 and 3, and also a function which throws an error after that random time intervals that is provided by math.random function. Now you can see on the screen the implementation of the simulation that we have created for forcing the server to go down after a random interval of time. Now we will start the server. As you can see on the screen that all the processes are running on port 3000 controlled by the primary or master process. Our server served the request for some interval of time, but then when the error was thrown, all the server exited one by one as they all faced some error in random intervals. In real life situation, when we have one server to serve the requests, and if that server goes down, our services will be down until we start our server, and in that period of time the incoming requests will not be served. But now we have multiple processes, and if one process goes down, we still have other processes that can serve the incoming requests. But if all the processes go down, we will have to have a way to tackle this setback. Now we will have to deal with the situation in such a way that if we notice a process is terminating due to some error, we will respawn new process in that place. But we know from the previous video that we can only fork a cluster in a primary process, so we will handle this issue when the process is primary. But before we do so, we will go through NodeJs documentation to find the solution. So we will go in the cluster module and see what we can do to handle the above scenario. First of all, we will go to the cluster.fork method because we discussed that we can only use cluster.fork in primary process. See, here it is mentioned that this method can only be called from the primary process. Now we will go to the top of the documentation. See, here are some events for workers like disconnect, error, exit, and so on. And if we scroll down, we have some events for our cluster, then we have some methods and properties for our cluster. Now let's check exit event for workers. So here, when process is primary, they are forking a worker and they are listening to exit event. They have some conditions for it. But if you look above, they have mentioned that this is similar to the cluster.onExit event, but specific to this worker or process. So this event is very specific to single worker, but we don't want our application to restart a single worker, but we want it for all workers. So let's have a look at cluster.onExit. See here, cluster is listening to the exit event, but they have also mentioned that if when any of the worker die, the cluster module will emit this exit event. So this is the perfect event for us to use, and if you have a closer look, we have access to the exit code and the worker itself. So using this worker, we can check whether the worker died due to an error or closed intentionally. For that purpose, we have a property in the worker called exited after disconnect that tells if the worker was exited intentionally, this property will be true, and if the worker exited any other way, the property will be false. So we will use this property of the worker and the code parameter of the exit event of the cluster to deal with our scenario. So the condition will be like if we have a non-zero exit code and if the worker died due to another reason, we will start or fork a new process. So if we use this condition would be like code not equal to 0 and worker dot exited after disconnect is false, we will start a new process by using cluster.fork method. Now we will start the server and load the server with autocannon and inspect it, that if our server still shuts down like the previous one that we saw. Now you can see on the screen, if one of the process goes down, it is started again, and our server is serving the request even if we get some error without any downtime. And even though after the stress test is complete, the server is still running.